Okay, so we are asked to prove the following logical collection of Boolean variables is a contradiction. And what that means is it means that we have to show that it's false for every possible input that can go on. Basically, whatever the values of P and Q are, we're going to get something that's false. Right? So one way to do this is to do a truth table. So let's go ahead and draw that out. Go ahead, Q, P, Q, or Q, and not P. And then finally, there's not enough room to fit all of it. We'll take this entire thing right here, and we'll put that right there. Okay. So the way we show, that was to clean this up a little. Okay. So the way we show that this is a contradiction is we show that the final column is going to be false for every value of P and Q. Let's go ahead and crank this up. So we'll do the standard TT, TF, FT, FF. Those are our four possibilities. Okay. And now not P, remember not P is exactly the opposite. So not P is false, false, true, true. Okay. The same story with not Q. Whenever Q is true, not Q is false, and vice versa. So here we'll have a false, true, false, true. And then finally, P or Q, recall, is the logical statement that is true whenever P or Q or both is true. So in fact, we'll have a true, a true, a true, and a false. Right? The only way for P or Q to be false is if they're both false. Now, let's look at the next expression. Let's notice, first of all, there's an and here. Let me highlight that. And with an and, you need both things on this to be true. Okay. So let me go ahead, or to say this another way, if either of the things on the left or right-hand side of the and are false, the whole statement is false. So let me go through it. I'll mark the false here, the false here, and the false here. So P or Q is false in the bottom row. Not P is false in the top two rows. Therefore, this and must be false in all those cases. We don't have to check anything else. So I just get a false, and a false, and then finally I expect this one to be a true, and we see that that is not P is true, right here, and P or Q is true here, so therefore I get a true. All right, now, there's those, same story. Okay, if I now look at the and here, right, notice that since this is an and, it'll be false whenever either side of that and is false. So I'll go back here and I notice when is not Q false? Not Q is false here and here. This triple term is false here and here and here. And you see every one of these rows contains at least one highlighted term, right? So false and false is false, true and false is false, false and true is false, and true and false is false. So what we have here is we have shown this entire column is false, and therefore we're done. That's it.